One particular group of fungi are the ones that are used in production of cheeses. So you think about things like the blue Stiltons, the gorgonzolas, also the camemberts and the brie, so delicious cheeses. Problem is, though, that there's only a limited number of cheese fungal molds that can be used to produce those cheeses. So we're restricted in the flavors. And also, in evolutionary terms, there is a risk that gradually they're becoming worn out because they've been reproduced by a method of reproduction called asexual reproduction, where you copy from the parents, but gradually they do lose vigor. So that's the problem. We only have a limited range of cheese flavors available. The way that we've looked at this is we've been able to discover a way to sexually reproduce the fungi. So beforehand, no sexual cycle was known. And as is the case in sexual reproduction in general in the animal and plant and fungal kingdoms, when they sexually reproduce, you get new progeny, like little babies coming out. And the babies might be similar to the parents, or they might be between them, or they might be something completely new. We then took the progeny, and we had literally hundreds of them, and then used methods to look at the flavors. And using some lab techniques, we're able to predict lots of different new flavors. So some hybrid flavors between the gorgonzola and the roquefort or Stilton, but also some entirely new ones. And also in terms of health, they had low, although they tasted salty, you could use lower salt to produce them. So from a health point of view, not only did you get better flavor, but you also had health benefits. There are also benefits in terms of sustainability and efficiency. So the strains we've got, because they've restored their vigor, because sexual reproduction restores you almost to your default young self, it means that there's less cheese waste, because often when the producers are using the existing strains, about 10 to 15% of cheese production fails, and they get low-grade cheese, which has to go to waste. And one little spin-off work that we've been doing is to produce new colors of blue cheese. So you think blue cheese is traditionally blue-green, but via our breeding technique, we've been able to produce reddish-brown, bright green, light blue, and even white strains. The blue cheese market has been static for 50 to 60 years. And we've been told by producers we've worked with that this is the first innovation they've seen in almost a century of blue cheese production. So we've now got producers, for instance, up in Scotland that are trialing our new cheeses. And also in Europe, we've got, I think, about 5 different producers in Europe. So from a commercial point of view, these are very valuable. And it led to the formation of Myconeos, which is based in BioCity in Nottingham, where we are producing the strains. And we're now selling the new strains in Europe and the UK to start with, but we have got patents covering them worldwide. Looking to the future, we've already developed the new strains, particularly the blue cheeses, and now we're moving on to look at the outer mold ripened cheeses such as brie and camembert. And that, in fact, is a bigger market. And we've used the same technology that was developed at the university for the blue cheeses to now look at the outer brie camembert ones. And very exciting to say, we've made a big breakthrough in the last 6 months in getting sexual reproduction working in those.